Questo è il tipico cervello che uno sempre
This is the older brains. So what we can see there and not there. So. So you can see that we have here the third ventricle, and then we have the opening, one opening below the septum pellucidum to the lateral ventricles. And here the septum pellucidum is rupture, and you can see the whole lot of parts of the ventricles. So we have the frontal, parietal, occipital, and then the temporal part of the ventricles. We can see there that the ventricles around some center, and this center it's the thalamus. So the encephalon with the thalamus, it's like a center, and then for example, these plastic structure, this is the part of the basal ganglia, nucleus caudatus. So the nucleus caudatus copy and go around the thalamus. And more laterally, the lateral ventricle. So you can see that it's a prominentia to the left lateral ventricles, and a lot of parts are inside the cerebrospinal liquid.
This is the thalamus.
This is the thalamus. So this is like an egg of the brain. You can see there that the thalamus is this is, but the roof of the third ventricle is there. So that means partially the thalamus is inside the third ventricle, and partially it's not. So it's the normal. So here is the cerebrospinal liquid, here not. Yes. So it's a difference of the encephalon. And now back, when you see this nice brain, so you can see the attachment between right and left thalamus. So this is the adhesio interthalamica. And then you can see the roof of the third ventricle. And the end of the or dorsally, the end of the third ventricle, we can find here the epithalamus, and this is the epiphysis. So you can see there the epiphysis, this one, and usually it's above the lamina quadrangularis, and it's look like a fifth tubercles, but this is the part of the diencephalon. Yes. So do you know what is good for the epithalamus, epiphysis? What is the function of the hypophysis? Epiphysis. Sorry. What?
No, epiphysis.
I don't know. I didn't. Epiphysis. Melatonin. So this is the pathway with the retina, if it is light or dark, and by this produce melatonin for the sleeping or not. Yes. So this is a very important gland. When you travel, you can take the melatonin if you fly to the east, because it's difficult to change the rhythm. The next, what you can see there, it's the triangle which is located there. So below the thalamus we have here hypothalamus. So it's like a triangle which in the transversal section looks from the side. It's the thalamus, adhesio interthalamica, and the hypothalamus. But when we make the transversal section, it's like a part of the white matter, and inside again some nuclei. And here is the thalamus, and here. Yes, so it's like the conus, important. Do you know how we can? What is the function of the hypothalamus? Which type of the nuclei we have here? Hypothalamus. So it's a highest reflexes. Yes, thermica. So we have here the centrum of the thermoregulation.
Hungry.
Then thirsty, hungry, and it's if you're full. And then we have the system which is connected with the limbic system in our brain. So that means here it's the beginning of the pathways for the sympathetic and parasympathetic innervation. Yes, so we have here the centers of the blood pressure, about these regulation of the water, yes, and so on. And every these important things are there. Then we have here some nuclei which produce two hormones and send it to the hypophysis. So that means the oxytocin and vasopressin, antidiuretic hormone, and this is the special nucleus. In this part, in the hypothalamus, we have some center which is connected with the retina, and this is the point where you can recognize dark or light, and then it's sent to the epiphysis. Yes, so the center is there, and then the information go to the epiphysis. Yes, and more higher. So the brain like the telencephalon. So the telencephalon, you can see that we can recognize some lobes. Oh, no. Some lobes. In the center, we have the central sulcus, and in front, we can find the gyrus precentralis and gyrus postcentralis. It's a very long gyruses where we have the map of the motoricity or map of our body of the sensitivity. It's postcentral. More than in front of the central sulcus, we speak about the frontal lobe. So the frontal bone has the end somewhere here, but the frontal lobe it's there. It's a bigger. Frontal lobe it's bigger because we need more neurons for the regulation of the movement. So a lot of parts are there, like a premotoric and supplementary motoric area and so on. Then we have the parietal lobe and parieto-occipital sulcus and the lateral sulcus. That means temporal lobe and parietal separate. Yes, this is the first description. So on the some gray matter is typical localization for some typical function.
Michele.
Quello lì è intero
On the top of the temporal lobe, we have the specific primary cortex for the hearing. All parts of the occipital lobe, it's full of the visual recognition. Then we speak about the frontal lobe and the motoricity, but this part of the frontal, the prefrontal area, it's about the high thinking, like our identity and character and so on. So when you destroy, you change your character, for example. What we can see in the medial side, so in the medial side you can see that we have here the parieto-occipital sulcus, and this sulcus, it's the sulcus calcarinus, and around this sulcus we have the cortex for the visual area. What is important, the right and left hemisphere is connected by the white matter, and when the connection is the same place on the right and on the left, so we speak that this is the commissure. And this commissure name the corpus callosum, it's the biggest, and connect frontal, parietal, small part of the temporal, this acoustic pathway, and then the splenium, it's for the vision and occipital lobe. So it's a very very nice and typical number of the fibers. It's a lot of millions there. Above this corpus callosum, we have some special gyrus. This is the gyrus cinguli, and this gyrus, it's connect with the internal nuclei in the temporal lobe. And this internal nuclei, it's the part of the limbic system, like amygdala and the hippocampus. And the limbic system, it's necessary for the memory, and then for the emotion and sexuality. So it's a connect straightly with the olfactory nerve. So usually these impulses is under our consciousness or focus. So when we smell something, we make some reaction by the autonomic nervous system, for example. So it's a very strong reaction in our body. When you are nervous, it starts to be active, the sympathetic fibers, and you are red or wet, you start to sweat. Yes, so it's this reaction. Or if you feel you feel some bad smell, you can start to vomit, because it's like a parasympathetic reaction, coughing and vomiting and so on.